Hello everyone, welcome to Chemazon-Complete Chemistry. In today's video, we are going to learn what is Hooke's law, which is for harmonic oscillator, and the same concept will be useful for us to understand the infrared spectroscopy, that is molecular vibration in organic molecules. So one of the result of this Hooke's law is what we are going to learn and understand. So the first equation here that you can see is for the Hooke's law, that is F is equal to minus kx. This is the equation of the Hooke's law, and this nu and nu bar, that is the expression for frequency and wave number. These are the results that we are going to use, and we are going to also see the derivation of these equations so that we can come to know exactly how we get these equations. Okay, so we are going to see the derivations as well. So let us first understand. As we had seen in the last video, we consider, let's say, a diatomic molecule. Again, let us consider HCl. This is connected by a bond, and let's say that bond, it is like a spring. Okay, we assume the bond to be the spring, and this can vibrate. So what will happen is, this is the equilibrium position. This is the equilibrium position of the molecule. Okay, now what I will do, I will apply some force and move this like this. That is, I will stretch the bond. So what will happen is, the bond length will increase, right? So initial length was this much, bond length was this much. The new displacement that I've created, that is what? That is x. Okay, displacement that I've created is in this direction, and because of this displacement, what will happen? There is another force in the opposite direction that is present within the spring, that is called as F. That is a spring force. Okay, F is the spring force. Okay, force that will pull this bond together, or pull this spring in the opposite direction. So this spring force is directly proportional to the displacement x. More is the displacement, more will be the spring force. Now if I want to remove this proportionality sign, I will add a constant that is called as k. K is nothing but it is called as spring constant. K is the spring constant. And now you can see that the direction of displacement and the force both are opposite in direction. So I will add a negative sign. What does negative sign indicate? That both the directions are opposite. Okay, so this is the equation for the Hooke's law. F is equal to minus kx. Okay, what is for F? F is the spring force. F is the spring force. K is the force constant. And x is what? X is the displacement from the x is the displacement. Okay, so now what we have to do is, we have to derive the equation for the frequency. Nu is what? Nu is the frequency. And also we have to derive the equation that will be useful for us in infrared spectroscopy, that is for the wave number. Okay, so let us start. So we have got one equation, force is equal to minus kx. And from the second law of Newton's second law of motion, we know force is also equal to m into a. M is mass, a is acceleration. So what we have to do is, we know the expression for displacement from the stationary waves. It is what? It is a cos omega t plus phi. Okay, what is x? X is the displacement, a is the amplitude. What is amplitude? Amplitude is the maximum displacement from the mean position. Okay, and omega, so basically a and omega, they are what? A, omega and phi, they are what? They are constants. Okay, now what we have to find out is, we have to find out the expression for acceleration using this displacement. So what is the formula for acceleration? Change in velocity with respect to time. And what is velocity? Velocity is what? Change in displacement x with respect to time. So if I multiply this, this will become d square x by dt square. So this expression of x, we have to double derivate. That is, we have to derivate it 2 times with respect to t. T is what? T is time. Okay, so before doing the derivative, what we must know is, we must know some of the very important formula of derivatives, like d by dx of x raised to n is equal to n into x raised to n minus 1. Okay, suppose I want to find out the derivative of x raised to 1, that is derivative of x with respect to x. So this will be n is 1 into x raised to n minus 1. N is 1, so 1 minus 1. X raised to 1 minus 1 is 0. So x raised to 0 is what? 1. So 1 into 1 is 1. So derivative of x with respect to x is what? It is 1. Okay, d by dx of x is 1. Then what we must know is derivative of a constant is 0. Okay, if constant is in addition term, then it is 0. Then derivative of sine x is cos x, and derivative of cos x is minus sine x. Okay, these many formula are enough for now. Okay, these are the very important formula that you have to remember. Okay, so now we can do the double derivative. Okay, let's say I do d by dt of x. Okay, the first derivative we are finding out first. So d by dt of x is what? X is a cos omega t plus phi. Omega t plus phi. So what is the derivative of cos x? We saw just now. Cos x is minus sin x. So a is a constant, so I can bring that outside. Cos theta is what? Or cos x is minus sin x. So I'll write minus sin x. Here it is this term, omega t plus phi, into the derivative of this term, okay, in the brackets. Okay, derivative of omega t plus phi. This will be derivative of, okay, with respect to time, right? So derivative of this with respect to this, omega is constant, and derivative of t with respect to t is what? It is 1. So omega into 1 plus phi is a constant, so it will be 0. So what we got is omega. So the final expression for displace, the first derivative is minus a omega sine omega t plus phi. Okay, minus a omega sine omega t plus phi. Now what we have to do is we have to do the double derivative. Okay, now we have to do d by dt of dx by dt, the expression that we have found now, that is minus a omega sine omega t plus phi. Okay, so minus a omega is constant, let us keep it as it is, and derivative of sine x is what? It is cos x, that is x here, it is what? Omega t plus phi, into derivative of omega t plus phi. Okay, so this will be minus a omega into cos omega t plus phi, into again the same thing, derivative of omega is constant, derivative of t with respect to t is what? It is 1. So omega into 1 is omega, plus this is constant, so that will be 0. Derivative of constant is 0. So the final expression for d square x by dt square, that is nothing but acceleration, is minus a omega square cos omega t plus phi. Okay, so now what we can do, we can again use that expression, F is equal to minus kx is equal to mass into acceleration. Now we can substitute minus k into x is what? A cos omega t by cos omega t plus phi, and mass into acceleration is, we have just found out, it is a minus a omega square, okay, minus a omega square cos omega t plus phi. So now if you compare both of these equations, minus is common, then a cos omega t plus phi is common. So what we have got is k, okay, the force constant is what? M into omega square. Okay, now what is k? K is the force constant. Okay, M is what? M is mass. And omega is what? Omega is the angular frequency. So what we want here is, we want the expression for omega. So omega square is k by m. Omega will be root of k by m. So this is the important relation that I needed. Now we can use this. Omega is equal to root of k by m. What is the relation between angular frequency and 2 pi nu? That is linear frequency is this. Omega is the angular frequency and nu is the translational or linear frequency. We have to find out the expression for nu, right? Nu is what? Nu is frequency. So nu will be omega by 2 pi. Now substitute. What is omega? Omega is, so I can write 1 by 2 pi root of k by m. So now I have got the expression for frequency. Okay, frequency, the unit is hertz or second inverse. Okay, but for studying infrared spectroscopy, we need the expression for wave number. Now, why do we calculate wave number? We have seen in the last video what is wave number. It is inverse of wavelength. Now, whenever you incident any molecule with some electromagnetic radiation, what will happen is it will absorb light of a particular wavelength. Okay, but wavelength, if you see, let's say I take any random number, 200 nanometers. Okay, so if I convert this into meter, it is in the terms of power. So you can see it is very difficult. If I want to compare this wavelength with some other wavelength, it is not very convenient to compare numbers with this value and then power. So what we do is, for convenience, we find out the wave number. Instead of wavelength, we consider the wave number or the stretching frequency. Okay, stretching frequency, for example, it is 4000 centimeter inverse. If I want to compare this with, let's say, 2000 centimeters, so it is very simple. 4000 is a larger number, 2000 is a smaller number. So that is the reason why we use the term stretching frequency or nu bar. Okay, stretching frequency or nu bar. So we have to find out the equation for this nu bar. So we had also seen one equation, that is speed of light is what? Speed of light is frequency into lambda. Okay, so frequency will be c by lambda, and 1 by lambda is what? Nu bar. So c into nu bar. So suppose I want nu bar. How will I calculate nu bar? This is multiplication here. On the left hand side it will become division. So nu divided by c. So this is another important equation. Okay, nu bar is what? Nu bar is wave number. What is wave number? Number of waves passing through a unit distance. Okay, number of waves passing through a unit distance, let's say 1 centimeter. That is wave number. What is this nu? Nu is the frequency. And c is what? C is speed of light. Okay, so now this we can substitute and find out the value of nu bar. So what I will do, I have to divide both the sides by c. So the final equation that I get is nu by c is nothing but nu bar, which is equal to 1 by 2 pi c root of k by, here in case of infrared spectroscopy, we substitute mass with a term called as mu. Mu is what? Mu is the reduced mass. Okay, we will see what is reduced mass. Okay, this is the final equation that we are going to see. Okay, that we have to understand. Okay, so let us first see what is reduced mass. Okay, suppose there are two atoms forming a bond, let's say mass m1 and mass of other atom is m2. So what is the formula for mu or reduced mass? Is 1 by m1 plus 1 by m2. Okay, cross multiply, this will be, sorry, this is 1 by mu. Okay, so 1 by mu will be m1 plus m2 divided by m1 into m2. So we want mu or the reduced mass. So we will take the reciprocal, m1 into m2 divided by m1 plus m2. This is another very important formula. Okay, so from this entire thing, what you have to remember, one is the F is equal to minus kx. This is the Hooke's law. For infrared spectroscopy, the very important formula is nu bar. That is 1 by 2 pi c root of k by mu, that is reduced mass. What is nu bar? It is wave number or called as stretching frequency. C speed of light, k is force constant, mu is reduced mass. Okay, so this is very important equation that we require. So in the next, so this is the end of this video. I hope you have understood the definition of wave number and its derivation. And in the next video, we are going to see what are the different factors that affect the stretching frequency value. Thank you.